So our presenter today will be Sir Michael Dorka, the Chief Design Officer at Ant, and I will be going over design thinking process and everything that involves design thinking. So I'm just going to hand over to him now. Let me stop sharing. Moments.
So here we go. Hello, everybody. Can you see my screen?
Can see it.
Awesome. Here we go on full screen now. Cool. No, I want to exit full screen. I want to get into presentation. Awesome. So my name is Michael. Friends call me Mike. And I am with Google as a Google developer expert for like 6-7 years. I'm also one of the anchor mentors from originally Google for Launchpad, which is a program now better known as Google Accelerator for Startups. And I have to correct myself that at this point, I am not the Chief Design Officer at Unk anymore. I changed that like almost a year ago. And I am working now as a consultant in different companies. So what are we going to talk about today? I'm going to try to be as fast as possible within the next probably 40 minutes. We're going to talk about design thinking and about design sprints. I'm trying not to get too profound into the design sprints. This is an introduction talk about it. I want to share with you my experiences basically in startups about how we create digital products. That's why actually this presentation is called Creating Digital Products. And it's not called design sprints or design thinking because we will see how design thinking and design sprints actually work for creating digital products. And one of the main reasons why it is so important for me to talk to you guys, besides that I'm already working almost a year with a Jamaican company and with Jamaicans, it is because it is important to understand what the developer's role is actually within creating a digital product. The digital product could be anything, could be an application, could be a website, could be software, could be SaaS, could be whatever is a digital product. But you know that you never work alone and you always work with a team. As you can see here now, I pointed out like 4 main teams. There are probably even more teams participating, but one is the design team, the other one is the research team, the other one is the developer team, and the other one is usually a product team. I will focus in this talk more on your perspective on how I think you guys should participate within these processes, what you can expect from design thinking from your point of view, what the others expect from you actually participating in these kinds of processes. I'm going to share this slide at the end with the other guys, so you don't have to take notes. Take notes if you have questions. So I would rather prefer to go through the presentation and you guys taking notes of the questions that you maybe got, and then at the end of the presentation we're still going to have some time to talk about this. You know, when you create a digital product, there is usually like a strategy that everyone wants to have, right? So you have this master plan on what you're going to do, how you want to create this product, and how to interact with all the participants. But usually it is not that way. And usually it is like a real mess. So let's get an idea of what design thinking is, right? Design thinking is helpful for solving problems and for identifying the unknown. So what do I mean with identifying the unknown is if you have a problem and you don't know where the problem is or why it occurs or what is happening even when coding or when designing or defining a digital product, design thinking is a way good method to figure out where the problem is. It is an iterative method, which means like you have certain states of iterations. You work on something that in the industry you call the MVP, um, which is the minimum value product, which means you don't look for the perfect outcome when you're working in a design thinking process, but you work on on an outcome um, in which you want to get really fast and which still delivers a good experience for the users, but more importantly gets you a lot of information about how people interact with your product and or how they don't, because they might have problems. It is user-centered. Design thinking in its origin came from IDEO working with D School from Stanford. And they figured out that all the designing and all these iterative processes, they don't make sense if not a team is involved. So that means basically that all the non-designers have to understand a minimum of design. And not only that, they have to participate on design. And that got really important when also Google was looking with Google Ventures on their startups, because they figured out usually startups, when they kick off in the first initial phase, they're usually like 3, 4, 5 people. And you may have the luck that you got someone designing and someone developing, but that's pretty much it. And then everyone has to do a little bit of everything. And that makes it so necessary that everyone understands that the responsibility is way more than just fulfilling your part in coding or in designing or in planning, but also you have to participate in creating this new product. And this is way more than just your hard skill that you already got. The mindset for design thinking, you have to be optimistic. As I mentioned, it is user-centered. You have to embrace ambiguity. You have to learn from failures, because this, when we say we work in iterations, this is what it basically means. You're gonna fail. What is important is that you don't fail twice or 3 times in the same thing. So if you do mistakes, that's okay, if they're not fatal, obviously, but you should not repeat the same mistakes on the same things. And that's the reason when you learn, right? So learn fast. You have to make things. Design thinking is not a theoretical work. You have to actually create something. As I mentioned, you have to iterate. And as I also mentioned before, you have to collaborate. And this is really, really important because, again, since it is human-centered and you need optimism, you also have to create confidence and trust in the other one. So if you're working with designers and you guys are developers and you're working with product people, you're working with marketing people, and even in between developers, you got the front-end developers, back-end developers, you have to create this trust, and that that everyone is just aiming to get the best out of this product, and that everybody knows, like in a soccer team, that only everyone participating and passing the ball will end up scoring. So in the design thinking process, this mindset is crucial. Let's compare a little bit on how it was before, right? And what we were so used to in companies, like avoid failures, sustaining order, everything is so orientated in a hierarchy. Get it right in the first time. Certainty is key. Thinking, facts and numbers, logic and standardization, And now it's all the opposite. It's fail fast, break things, fail fast. Maybe, as I said, fail fast but not fatal, because you have to return. Take risks, iterate, embrace ambiguity, do the stuff, Don't only think about it. Focus on storytelling, not only in facts and numbers. Facts and numbers do matter. It's not that we replace them, but focus on storytelling. Create empathy, be emotional, humanization. Know that humans are creating a product for other humans. It's not that you're just designing code and you design the code or you create the code for the code itself. You do it for someone else. You do it for someone actually using the service based on your code. It's an iterative process. We redefine problems. We have to promote a solution-based approach and not always focusing on this is bad, this is not working. Okay, cool. So let's figure out how we can solve that stuff. As I mentioned before, develop empathy with the user. This is why we talk about user centricity, right? You have to feel this empathy. And again, I want to underline that because it's so important. A product doesn't end with the code, and the objective of a product is not the code. It's based on the code. Your code is the water and sun for this awesome plant that you're creating. But this plant is for someone else to use, to see, to look at in an environment. Your code is the base for it, but don't stop at the code. Think ahead, like what else is important, right? And okay, it is a hands-on approach, prototyping and testing. So this is also something really important. I don't know if it happened to you guys, but when you work in a multidisciplinary team, right? How often does it happen that someone says, okay, let's do this product and you guys have to code. And then a week later, someone says, no, this did not result very well. Let's do it in a different way. And you have to code. It is way easier to get these same insights from users interacting with a product by creating prototypes. You don't have to code for that, at least not on the first stage. So it is important to know for the others who are participating in this design thinking processes, like for instance, design sprints, that this is also a philosophy that is based on respect on the others. Like again, what does it matter if a designer designs a super nice interface for a digital product or website, for an app, and the developers don't say that they can actually not create the code for that, or they cannot develop the product the way the designer designed it. So what happens? The designer has to iterate again. So it is common sense to say, hey, talk before actually designing, talk before coding, create something together with the least effort necessary, and create something that gets you results from users interacting. So again, there are like three components. Technological possibilities, this is what I mentioned. This is your part that you bring in. Hey, what is possible? What is not? What is state of the art? A designer has no idea of what is state of the art. So design thinking also means for you guys to explain to non-developers what is state of the art. Where are the limits? Where are the challenges? Where are the easy ones, the low-hanging fruits? Business success. It is obvious, like we don't make this effort without taking an account of what the business success should look like and what are the user needs. Understanding user needs, explore by finding patterns, prototype by providing specs, evaluate by always iterating. This is probably the most important part. This is the typical design thinking process, right? You diverge, you converge. You create choices, you make choices. This is the glory diamond that everyone talks about, right? This is where the difference happens, right? And the most important part of all is you don't have a specific place in here. You have to participate at all moments. You as a developer as the designer, as the product analyst, as the marketing person. They have to be on board. They should participate. They should know. They should also decide and create. Now we can see how it is more explicit within this diverge and converge and iteration process. So you see here that we have the double diamond now. We start with understanding what the problem is. We empathize with the users. We define where the problem is. So, a simple example. If you have a blue screen in Microsoft, in Office, right? We have to empathize, thinking of, hey, when this blue screen occurs, what will the user actually feel like? I mean, how would they feel? Would they understand what is happening when they see a blue screen? So then converge, let's define. So where is the problem actually when the users see the blue screen? Is it because of the words used, the codes used? Do people understand what is actually happening? And then we create the diverge. Okay, so we have this blue screen. How do we change the text here that someone actually understands what is happening? Someone who is not a developer. Then you converge. Let's prototype this screen. Let's figure out how people actually react. So let's do a test. Let's create an interactive prototype. Let's see what happens when a user actually sees our new blue screen. And we test it. And this is the deliver part. We have usually some sort of research. And again, thinking at this point is sort of important. It is not that we stop with thinking. That's the main difference. The focus is on doing, but we start with thinking. Think before you talk. Think before you design. Think before you code. And think together. Define the problem to be solved. This is so important because there are usually a lot of problems that people can actually be confronted with, users, but focus on one. Don't focus on all of them. You can, anyways, this is a process that's repetitive, so you're going to repeat it anyways. You don't have to worry that you miss out something only if you define one specific problem. Ideate through, create prototypes, and test. I'm repeating sometimes here, but again, it is so important that you understand that this is a process. It's not a one thing that you do, a one moment where you say, okay, if you do it like this, everything is fine. No, you have to go through this process and pass through these phases. So here you see a design sprint. We're going to get into design sprint, what it is and how to apply it or when to apply it. But you usually, when you create a product, right, and it doesn't matter if it is now for commercial aspect or if it is a project within the university, you can start with a design sprint. So these design sprints, the design sprint is actually a method for design thinking. Again, design thinking is the philosophy. Design sprint is the method to use, one method to use. Usually that works like a laboratory. Again, it is really efficient if it is for something new, if there is a problem, something unknown, something that you want to work together with a team, because usually some more heads are always more efficient than only one head. Then you bring it into an experiment. This is the lean part of it, where you might have to iterate. Iteration would be like this very little circle that you see. This is not obligatory at this point. Maybe in the first row, the first sprint, actually, you don't have to iterate, but then in the second or in the third sprint. Iteration could be in the first sprint, in the second, or in the third, on the fourth. It depends on how you define your sprints. And this gets into an agile production in which this process actually repeats. So design sprint, let's go for the very basic stuff on that, right? you do some understanding, as we said before. With qualitative or quantitative research, you might have, if you're creating, like, let's say you're creating a website, so you use Firebase or use other tools, Flutter, whatever you have, to get an idea of quantitative facts about the use of your application. And or you do qualitative research, you do interviews, people tell you, you have customer support, or within your peer group, within the design, within the student club, within university, you figure out where the problem is. You define the problem, you call it out, and you get like a contract on it. Like everyone gets into it and agrees on this problem. You ideate, as we mentioned before, David Converge, and you create a prototype and you validate. Then you get it into this lean part, right? So once that you got it moving, you want to learn. You build the stuff, you measure it. This is like the real McCoy. This is already getting out of this design sprint phase. This is already like production. You figure out if you have to iterate or not, if you have to pivot or not, and then you get into the agile part. And this is, again, the sprint planning, execution, daily scrums, daily stand-up meetings, sprint reviews, shippable increment, and sprint grooming. This is like a zooming out of a global process, right? So you wanted to know about design sprints. Again, as you can see, these design sprints have some sort of efforts, but there are different reasons why to apply a design sprint, and there are different design sprints actually that you can run. If you have a non-critical adjustment, usually it is based on a heuristic analysis and best practice. If you don't know what heuristic analysis are, don't worry. At the end of the presentation, there is a link where you can get more profound ideas of what these heuristic analysis or rules actually are. But I give you an example. If you have, again, a user interface in which there is a button and the contrast makes it not readable, so no one actually notices this button, you have to improve contrast. This is one of the heuristic rules. This is really easy to handle, and that takes you just a day. Do you have some sort of research for that? Yeah, maybe, because maybe you know from your analytics or from your Firebase or Flutter or whatever you use that something is wrong because nobody actually is interacting with this button. And do you iterate? Yeah, you could, because you could actually have different colors or different forms of this button. And you can test it if you want to. And at the end, it's one day. You don't have to run a very complex process for that. It is bringing down or breaking down a whole design thinking process in one day and make it really simple. Then there are critical adjustments. This might have like strong negative or positive impact on the user experience. Strong negative impact is if there is a call to action, for instance, which is so crucial that the people have to touch and they don't. And so they can not, for instance, register. This is crucial. If they don't do this, they won't get to the end. So you might want to take that more serious. And that's why it might need more research, more ideation, more iteration, and a little bit more of testing, and you will probably result in a 3-day design sprint. And then there is the unknown, the innovation part. So you have this crazy idea about a super improvement of an app, a new something, a new feature of your app or your website or your service or the machine you're creating. And it is so brand new that research takes a little bit longer. It's a little bit more profound. And the ideation, the iteration will take some more time. You will need probably a little bit more testing, and it's going to take you a little bit more time, probably like 4 or 5 days. So are these golden rules? No, they are not. These are just based on my experience. Maybe you're really, really fast innovation and you do it in 3 days. Maybe it takes you longer because there's so little knowledge about what you want to innovate that it's going to take you like 2 weeks or a month. This is all possible. It pretty much depends on the complexity of your tasks. So thinking, as we said, non-critical adjustment, it is almost not a design sprint. It is a sort of, but not really. But you have like these three phases. You define what you want to do, you sketch it, and probably you code it. Or you define it. If you have a design library already, something like material design or a proper design library, you don't even sketch. You just use your library and you code, and off you go. Now, for critical adjustments, as I mentioned before, this is going to take like at least 2 days, probably 3. And here it makes sense to have this small design sprint. You have this phase 1 of definition, you have this phase 2 of sketching, 3 you decide, 4 you prototype, 5 you validate, you test the stuff, and you do like a sort of a QA of your final design, you bring it into code. That's also easy. And then innovation, which is probably more complex. Here, usually, you have more days dedicated to these different phases. And as I mentioned before, this probably even varies depending on complexity. Now, here we have these, the perfect design sprint. These are all like activities that you would do, you would participate in the different phases of a design sprint, right? So you have one method which is called how might we, you got lightning talks, and so on and so on. You see them all here, and when you Google them, you will actually find all the definitions and how to apply them. But what is more important, usually, well, did I skip? No, I'm gonna have the screen. Usually, you will see in another slide, you don't go through all of this. You will see why is that. As I mentioned before, all the design sprints, all design thinking is team play, right? So usually what happens is all against all, like everyone says, no, most important is the success of the business. The other one says, no, the most important is the design and user experience. The other one said, no, the most important is actually the code. And this is like really, really bad. As we think now it should be, we talk about teams, chapters, cellulars. They all have different names, but what is meant by that is that different people work together. Usually in a team you have at least a designer, a developer, and someone from a product, especially if it is a commercial product, and you have research, and you have content, and these might be included in each of the teams, or maybe these are like providers for all of the other teams. But one thing is for sure, it is very different to how products were produced before that, in which you had like 4 or 5 designers working in one silo, research in another silo, developers in another silo, product in another silo, and code in another silo. And no one had actually an idea of how to work together. So that makes no sense. So what you see here is Navy SEAL Team 6. For me, I joined the military force for many years. This is like the optimum, not because I think everything should be solved by war, totally on the contrary. But what is the motto, the main theme of the Navy SEALs is for something greater. And most importantly, as a team. And as you probably heard before, in a SEAL team, there are 5 to 6 people participating, and all of them are experts in their fields. There are medics, engineers, and so on and so forth. So you would have these product teams. Again, this is like in a company schedule. You might even have this in university in which you say, okay, we have feature teams, feature team 1, 2, 3, 4, 5. The only thing which is important that you make sure that in each of these feature teams are developers, designers, well, product people, if it has like a commercial point of view, that you work with research people and you work with content people if it is necessary. So again, this, as we said, was the design sprint. Understanding, defining, sketching, deciding, prototyping, validate. It totally reflects design thinking philosophy. That was the original best practice, loved multidisciplinary teams in a design sprint with all the methods that they use. Again, you see down there the members: design, research, developers, and product. They should participate in all of this. But usually this does not really work because there is a agenda overload. A lot of people cannot actually participate in everything because someone would say, hey, I cannot come tomorrow to this meeting, I have another meeting. A business or a developer will say, I have to code another thing, I cannot join the meeting tomorrow. And then the design sprint seems to break apart. And here you see actually what I mentioned before. What are the people participating in which phase, and what are actually the methods that they use? As an example, in phase 1 of understanding, usually only research and product people participate and defining it. And they usually just do some lightning talks, some user interviews, and they create a user journey map. But this is crucial because you have to understand where the issue is. And imagine if developers who have to know what the problem is are not participating on this phase. And this applies throughout all the phases. You can see it here very clear. So developers. What is the point? Where do I think you guys are really, really crucial, and where you are missing and where you should not? Most often you're missing in the understanding phase. Because a designer thought that something would be cool to change, or a product person would say, yeah, we have to change the business, and so we want to change this feature, and so on and so forth. You're not there, and it's already a hassle. The same thing in the defining phase. How often did I hear developers saying, I don't like sketching? And this is literal. Like, you would have to sketch in this phase. I often heard that. I am not an artist. I don't like sketching. I'm not good at it. And funny enough, in a lot of occasions, the developers were actually the people who had the best approaches with their designs. Not usually the most beautiful designs, but the most logical. And also they knew what was state of the art. Prototyping, developers don't participate because, yeah, it's like this design thing, it's not real coding. So it is crucial that you participate also in the prototyping part. Why is that? Because you then again have a chance to say, hey, designers, this prototype, we will not be able in a short time to actually code the function or the interaction that you are proposing. So again, it's another moment where you can raise your hand and raise your voice. But again, we have to be real. So even though, as I mentioned, you should participate, and even though we know that you will not, there are some of the phases where you actually don't have to participate live. I would say, for instance, in the understanding phase, you could work easily with an open document. This could be like a Google document or even like a Microsoft Word document. Doesn't matter, as long as it is shared, in which you understand where the problems are. So designers, researchers, they create this document, this research document, and everything is reflected there. So you don't have to participate in person in a meeting, but you have to participate in reading this document. The same thing in defining the challenge of the design sprint. Then in the sketching phase, this is something where you should actually also create. Um, the designing phase, before COVID, everything was simple. Now, doing these deciding sessions on remote is sometimes sort of awkward because, people have different point of views. So they discuss on things. But it is a good point to be there in a live moment, but you have to document it anyways. In the prototyping phase, the developers can just watch what is happening. They don't have to create prototypes, actually, but they can just watch and participate by watching. Then validation, there is something like when you do the testing, again, where everyone should actually participate, but this could be, again, just documented. It doesn't have to be really a live moment where everyone has to sit together. Usually it is a situation when you create a user test in which someone is moderating this user test and others are just observing and they're creating a report. And then you have the QA. Well, in QA, again, it's a pretty much live thing, right? So designers and developers come together and say, hey, we have this final design that we want to code. We all agree on that. Let's see if we all agree on pixel perfectness before coding. Again, here are the different roles, what people would have to do. The designers in the understanding phase, they create the design benchmark. They might have some user testings of the actual design of the software. So they have a lot of understanding, a lot of insights. They're going to bring it into the report. They might have like an atomic library or like a design repository that they want to take into account. So let's say, okay, we have to redesign. Probably the issue is that this button is not working out. We have to redesign, but we already have a repository that we should take into account. Research people make a heuristic analysis of the existing product or solution. They offer best practice and they create something which is called the customer journey map, which reflects actually the way how users are interacting today with the existing product or benchmark products in case of innovation. You guys from the developing department, you bring in the state of the art of technology. What is state of the art? Where are the best practices? Where are limits and challenges? And product people bring in business benchmark, define what problem will be solved by what you're facing with your design sprint, how big the opportunity is, what evidence do you actually have? Because you can say, yeah, we think there's a huge opportunity, there's a huge problem, but how do you know? What numbers do you have? And you want to sync with OKRs. Then you define the stuff, again, the designers, they define design workshops, the date and who's going to facilitate. They define the delivery dates of the designs and the prototypes because they are usually in charge of that. The researchers, they recruit users way before testing, but for the testing. They define the date for the user testing. They define delivery dates for the testing scripts that you need and the testing reports. The developers, the delivery date, dry runs, stability testings for the final codes. And products should define success metrics saying, okay, if this process, this design sprint is successful, how are we gonna see it reflected? They create Jira tickets if you use Jira or whatever kind of ticketing system, and they create the delivery date for the MVP. So sketching, every team member should participate. You update the the document, everyone should update the document afterwards or meanwhile, sketching sessions. Designers usually facilitate and participate, but are they like obliged to be the facilitators? No, because also a developer could easily facilitate this kind of process. The researchers have to participate. They could use something like real-time boards or Miro or whatever you like to use. Mural is another one. Developers participate on the workshop, and the product people also participate. Deciding, again, everyone has to. The designers take into account atomic design best practices, research heuristics, you guys, technical opportunities, and product people, MVPs. When you decide on the designs that you created and the phase before the deciding. Well, here's the moment that you actually don't have to participate, but you should read the documentations. Designing the prototypes, like the screens, you might use Sketch, Proto.io. There are a lot of actually tools that you can use for prototyping. Researchers, they create the testing script and they synchronize with product people. And product people, again, they define success metrics for the use or for the test of the prototype. You validate. Every team member should participate as an observer. And that's important. And it's even fun to see because, you're going to see a cool video. And if you see it live, it's even funnier. If you see it recorded, still makes sense. And you see how people interact with the product that you coded for or that you're actually planning to code for. So if you know that there is a specific part within the product which is difficult to code, and designers and product people say, yeah, but it is so core for the use and the user experience. But during the user testing sessions, you actually see that nobody interacts with that. You could say, hey guys, did you see? Nobody is interacting with that. And it is so difficult actually to code. Why don't we just leave it for another sprint, for another moment? Visual QA, again, it is the alignment, the synchronization between the final designs, which are supposed to be coded. So you want to check that before actually coding it. And you also want to check the interactions of all the different states, because maybe not all states show up during the prototype user test session. And then you code. So here is the appendix. Again, this is something once you guys receive the deck that I'm going to share with you, you can all view through it, how stuff work, what is what, and there are a lot of definitions and even like hierarchies and responsibilities. And yeah, that's pretty much it. Here you see the links for the Design Sprint Kit from Google. It's from the official Google website. Then if you have some more questions, here's the website with all the experts from the GDE program from Google. And thanks a lot for your attention. Now we're open to questions.
Yes, sir. That was incredibly informative. That was really informative, sir. Sir, any questions now in the chat, guys? I'm not seeing any, sir. So I actually have a question.
Yes.
All right, sir. I'm more of the developer. I prefer backend development, and I'm not good at design thinking. How does one improve or practice? Because I'm more of a practical learner. I like to actually go in and do stuff. So how does one actually improve in design thinking?
how someone improves in design thinking, in applying, in participating, in doing. As I mentioned before, design thinking is doing orientated. So that you like doing, this is awesome. What is really important, and you know it probably better than I do, is you have to validate the effort that you have to bring into doing stuff. So design thinking offers you like a mindset, and design sprint a tool set in which you can actually say, okay, let's start trying small things, but let's try to process with different people. So first thing that I would recommend is think of something very, very small that you would love to solve coding. Look for some designers or a designer. And if you have someone who has experience on research, I know that user research in Jamaica is an issue because there's not a lot of experience with that. But there is a lot of material. There are a lot of YouTube channels and videos that you can see on how to do research or to motivate other people also to do research and work in a team and work in a multidisciplinary team and make a lot of design sprints, make a lot of them. And don't worry about failing and don't think about doing the perfect design sprint because the perfect design sprint does not exist. Is that an answer to your question? Awesome.
Yes, sir. Thank you.
No more questions?
Anyone else?
Hello.
Go ahead.
All right. Afternoon again, guys. Very good presentation, Michael. I would want you to, probably touch on some short disadvantages. Disadvantages in the case where, if the scope.
Mr. Damien, we're not really hearing you if you're speaking. Hearing him?
I'm hearing.
Hear no better?
Okay.
I'm hearing you. Mhm.
Oh, okay. Sorry. I guess my headset was a bit offset. So yes, I was asking if Mike could list out some disadvantages, so to speak. Disadvantages in the direction of if the scope hasn't been properly outlined. So, for example, you're to not have a case where you're tunnel vision into one direction when probably a phase within the design thinking was not properly outlined. It could be a case where a team member didn't properly define their respective area. But what is it? What are some disadvantages that can arise from actually applying this? I would push it as a framework.
Okay, that's an interesting question. To be honest, like a real disadvantage resulting from this mindset or resulting from this process, I don't know. I don't think that there is one. You might end up discussing a lot with your friends or with your fellows or with you guys who are working with you. You might invest time and maybe having little practice on these kind of processes, you have to invest more time than you expect, and it might take more time than you expected. So that could be something. Validation of time sometimes is difficult. So this is something that you have to gain with practice and with your experience. Again, what, as you said as an example, tunnel visions, I don't think so, because you just learn. If you don't repeat mistakes and if you don't make fatal mistakes, the learning is always good. And even if your learning is a tunnel vision and you say, hey, gee, I think we all originally thought of solving that problem, but we ended up solving something totally different. Or we focus only on this very little thing, but that was not the issue. Again, since you don't have to code for a design sprint, the coding is once you finish with a design sprint. So you don't have to code. Any failure happening through the design sprint, you as a developer will not suffer too much. So I don't know. It's probably, you could suffer discussions. You could suffer investing more time that you thought. But this is like the most crucial that I can imagine, to be honest.
So I'm assuming that probably the greatest loss that can occur then is just time.
Yeah, probably.
Okay, great.
More time, more questions, doubts?
Sir Michael, how long it takes? I mean, you and Damon were talking about time, but how long it really takes? You know, the average time.
You should be laughing because there is no average time. Like, as I mentioned before, it depends pretty much on the problems that you're trying to solve. So here, I don't want to forget to share this deck with you guys. And give me a second. I'm gonna post it here so I don't forget, because otherwise I always promise that I'm gonna share a deck and then I don't. The smallest or the least time to invest in a sprint is a day. But as I mentioned, a sprint could take easily a month or weeks or years now, but like weeks easily. And what I would recommend again is I would probably start with very small sprints so you gain experience and you gain trust and confidence with the people who you are working with. Is this an average? No, but my recommendation is do at least like 5, 6, 7 very small sprints of 1, 2, 3 days. Get comfortable, learn about the mistakes you do during the process, about time validation, how you estimate time, and how much time you actually spend. It's like documentation. Like if I would ask you, what is the average amount of documentation of a code? You'd say, yeah, it depends, because it depends on what you're coding. And that's pretty much the same thing. Is that an answer to your question? All right. Any more doubts or questions?
You can actually type it in the chat, or you can like.
Yeah, and ask.
All right. You can also follow me on Twitter if you want to. You saw my handle. It is Michael_Dorka. In there, I promise I only talk about design, about products, digital products and technology. I don't talk about football and soccer. I don't talk about politics. So if you want to get more information, you can also contact me on Twitter, text me there, and I'm gonna get to you back to answer your questions. Not necessarily same moment, but usually I respond to people who ask me stuff. So if there are not any more questions, I really appreciate your time, your interest, and have a great day in Jamaica all.
Sir, you hear me, sir? Yes. So we just like to say, on behalf of the Google Development Student Club, we'd all like to say a big thank you for taking the time out of your very busy schedule to explain what is design thinking and why it's so important in order to create an incredible product for a problem. Because honestly, I didn't know it was so important, and there were so many different steps and processes in this thing. So I really would like to say thank you. It's just a big help.
I appreciate it. This is the only thing that really motivates me, is helping you guys. I want you to be happy developers and, you know, studying in a happy way. And, you know, I'm going to be in Jamaica also this year. If I'm on the island, I'm going to let you guys know, and maybe we could even have a talk in person. So again, thanks a lot. And whenever you need a helping hand again, don't bother to to contact me. Thanks a lot, guys.